When we're dividing with radicals, there's a couple things that are going to make the problems a little bit easier. It's written right here in this rule. This rule looks a little bit confusing, so let me kind of translate this. If we have coefficients on the top and the bottom that can be simplified, we go ahead and simplify them. So if we have coefficients, we're going to reduce the coefficients. And then we're going to do the same thing with our radicands. We're going to look at our number on the top and the bottom. If we can, we're going to reduce the radicands. And then our last step is we're going to simplify what's remaining. Okay, so looking at example 397, we're going to look at our coefficients. We have 15 divided by 20. That's going to simplify to be a 3 on top and a 4 on bottom. If we simplify our radicands, we have a 108 divided by 2. If we divide that, 108 divided by 2 simplifies to be 54 over 1. So now let me write this just a little bit nicer. On top, I have 3 cube root of 54. On bottom, we just have 4. I'm not going to write the cube root of 1 because that just means times 1, which won't change anything. So now we've done those first two steps. We've simplified what we can, but I'm going to see if, or we've reduced what we can. Now I'm going to see if that radical, if that cube root of 54 can be simplified. We've got 2 and 27, 3 and 9, 3 and 3. We're looking for groups of 3, so I can take a 3 out. There's already a 3 out here, so 3 times 3 gives me 9. Cube root of, there's only a 2 left over, divided by 4. Once we do this, we do want to check and see if these can be reduced or simplified. In this case, they can't, so we leave it just like this. Okay, but one kind of kicker about working with dividing radicals is it's considered bad practice to have a radical left in the denominator. So anytime we see a radical in the denominator, we're going to do what's called rationalize it, which basically means we're going to get rid of it. We're going to clear it out of the denominator. And to do that, so let's put some notes here, to rationalize, we're going to multiply the top and bottom by something to clear the radical. And this something right here, this is what's going to help us decide what we're going to multiply by. So one thing to keep in mind is if I have like the square root of 5 times 5, I just get 5. If I have the cube root of 5 times 5 times 5, I just get 5. If I have the fourth root of 5 times 5 times 5 times 5, I just get 5. So when we're thinking about clearing those radicals, this idea right here is going to help us decide what we need to multiply by. Okay, so for example here, we have the square root of 6 divided by the square root of 5. We're talking about a square root. My index is 2. So to get rid of that on the bottom, I really need, it's what we talked about right here, I really need the square root of 5 times 5. Okay, so I'm going to multiply this by the square root of 5, multiply this by the square root of 5. So on bottom, what happens? The square root of 5 times square root of 5 is just 5. That's why we do that. On top, we get the square root of 30. We always want to see if this can simplify. Square root of 30 is one we've seen kind of frequently. This one actually can't be simplified, so we stop right here. One thing that's tempting to a lot of students is to say, oh, 30 and 5 can be reduced. Let's do that. Well, we cannot simplify something that's inside a radical symbol with something that's on the outside. So we leave our answer just like this. Okay, so on 399, notice here we have a fourth root. That's going to be really important here. So if I want to get rid of that in the denominator, what I'm going to have to do is I have 1, 2 right here. Just like we set up here, if I need to kind of cancel out a fourth root, I need 4 of these. So I'm going to multiply this by 2 times 2 times 2. And if it's a little bit easier to write, you could also say times 2 to the third power. Whatever helps you see what's going on a little bit better. We're going to do the same thing to the top, times 2 times 2 times 2. And let's see why that helps us. On bottom, we have the fourth root of 2 times 2 times 2 times 2, which is just 2. That's why we chose that, because it gets rid of our radical. And on top, we still have a coefficient of 3. And 11 times 2 times 2 times 2, or 11 times 8, is 88. We always want to check and see if it can be simplified. If we do the factor tree of 88, looking at, whoops, I need a fourth root right there, not a cube root. We're not going to have any groups of 4 that we can bring out, so this can't be simplified any further. All right, on example 400, we have 4 cube root of 2 divided by 7 cube root of 25. So a couple things to pay attention to. We're dealing with cube roots. And one thing that will make this a little bit easier is if we recognize that this is the same thing as 5 squared, 5 to the second power. So I'm just going to rewrite this. 4 cube root of 2 divided by 7 cube root of 5 squared, or 5 times 5, however you want to write that. All right, so if we want to get rid of that cube root in the denominator, I really need 5 to the third power, or 5 times 5 times 5. So I'm missing 1, so I'm going to multiply it by the cube root of 5 times the cube root of 5. On top, let's see, we get 4 cube root of 10. On bottom, we're going to get 7 times the cube root of 5 times 5 times 5, which is just 5. If we simplify one more time, we get 4 cube root of 10 over 35. And that's all that this specific one can be simplified. All right, and then this last example here, we're dealing with square roots. Square roots are always nice because we don't have to worry about how many times we need to multiply it. But on this one thing that might help us is if we go ahead and see what can be simplified first. So if we look at our coefficients, 6/12, I can turn that into a 1, turn that into a 2. If I look at my radicands, they can both be divided by 2, so I'm going to have 7 and 11. So let's rewrite this a little bit nicer. I'm going to have 1 square root of 7, or just square root of 7, divided by 2 square roots of 11. Okay, we're trying to get rid of this radical, so I'm going to multiply by the square root of 11. So on bottom, we get 2 times 11, and on top, we get the square root of 77. Square root of 77 can't be simplified. 2 times 11 is 22, and we'll leave it just like that. So when we're working with, anytime we're dividing radicals, we want to make sure that we never leave a square root in our denominator. We're going to rationalize it to get rid of that.